remember, they're to put in your mouth so you won't talk. That's what the point is. All right? So now, let's go ahead and start with today. Again, I cannot emphasize how simple these sections are. It's just a matter of just knowing the rules. All right? The problem is on the test, I think this goes up to like 10.7, so it's a really long chapter with a bunch of rules. All right? And then the very last one is the most important section. That has to deal with the equations of circles. All right? But right now, just remember the rules. Very, very basic. All right? So here we go. Now here, it says copy the figure and draw the common tangents. If no common tangent exists, state no common tangent. Now, tangent, again, has meaning in trig, and it also has meaning in calculus, and has meaning in geometry. All right? But a tangent line simply means that it touches the circle at one spot. All right? So if we are going to draw a tangent, this would be, is this the right one?
Yeah, but one thing. Yeah.
This is what's referred to as the tangent line. So look up. That's a tangent line. Now, common tangent just means that the tangent itself has to have the same line that's tangent to both circles. Is that possible? No, it's not possible. So there is no common tangent. Let me give you another example. For example, if I draw this circle and I draw this circle, you should be able to tell me that there are probably 4 common tangents. All right? Now, let's just take a quick look at that and make sure you understand. So if I draw a common tangent, it would probably look something like that. All right? Except that's not very good. All right, so this point right here, this point right here, there would be your common tangent. All right? Again, if I was looking here and I was looking here, those are common tangents. All right? Now, it looks like there's 2, but you have to remember the ones that can go diagonally. Right? So if I was looking something like right here, and I drew it down this way, you could see those are common tangents. All right, because the line, that single line, touches the circle at exactly one point. All right. Now, the other possibility is if you have circles that are tangent to each other, then right down here, that would be considered a common tangent as well. All right, so those are all the different possibilities. And again, if for whatever reason you're not quite understanding what I'm saying, you can just flip back in the book and look up common tangents, and it gives you all the possibilities and all the examples. All right, but generally, tangent just means that it touches the circle at exactly one point. All right, this is considered a secant line because it touches at what? 2 spots. All right, and I've always said it's kind of confusing because secant, there's a definition for secant in trigonometry, right? And there is a definition in geometry. All right, it seems to me like they should just use different words. All right, because it can be kind of confusing. All right, so now let's take a look at the question here.
These are the numbers today.
Oh my goodness. It's not that, it's just that I'm ready to go. I've already left this up here. You should have already had it done instead of talking. All right, here we go. Now for question number 2. All right, what do you think the measure of angle EGF is? 9 degrees. That is exactly correct. So now there is a rule. Anytime you have a line that is tangent to a circle, and you draw the radius to the point of tangency, it automatically creates a 9-degree angle. All right, so everybody just needs to put in there, that's a 9-degree angle. So the question is that a tangent line? Is that a tangent line? Right, obviously not. Because if it were a tangent line, then a squared plus b squared would equal c squared. Is everybody with me? So this whole length from here to here is 12, or I should say EF is 12. So if you wanted to check, it would be 6 squared plus 10 squared is equal to 12 squared. And we already know that is not true. All right? It is not true. So that is not considered a tangent line. That is not considered a tangent line. All right, so over here, on the other hand, now, it looks to me as if this distance is what they're referring to, is 24. So now again, on your exams, all right, your SAT, ACT, these are the types of things that they throw at you that can be misleading if you're not careful. All right, what I generally tend, or I would like for you to do, is to say, what's the radius of the circle? The radius of the circle is 15. So this also has to be what?
15.
15. Which means this EF is how much?
39.
Which is 39. Everybody with me on that? And then it would be the 5, 12, 13. So again, this is equal to 5 times 3. This is 5 times 3 times 12. And this is, right, so look at that, please. All right, look how much time you can save. All right, if you remember the triples. Again, just to make sure you want to write them down, 3, 4, 5, 8, 15, 17, 5, 12, 13, and then the other one is 7, 24, 25. There's a couple more, but generally I've found these are the problems that are in the book. So in this particular case, you can clearly see that a squared plus b squared is equal to c squared. So this is what? That is, yes, that is a tangent line. That is a tangent line. Anybody have any questions so far? I told you it's very easy.
So it can only be tangent line if a squared plus b squared.
That's exactly correct. All right? Because the radius to the point of tangent forms a 90-degree angle. All right, here we go. Let's look now at question number 4. All right, it says assume the segments that appear to be tangent are tangent. So in this case, we are trying to figure out what x is. And obviously x is 20. Again, this is what I'm trying to tell you. I want everybody to be able to recognize that. The first thing you should do is you should look up here and say, this is 4 times 3, 4 times 4, 4 times 5. So 20. All right. If you can't see it, you just have to do a squared plus b squared equals c squared. All right. Now on this case, might be a little bit harder to see. All right. This one's going to require some algebra. All right. Because AD is also what length? X. Very good. It is X. Everybody take a look at that. All right. Now we got to work on the algebra now, right? Because it's just a squared plus b squared equals c squared. So x squared plus 30 squared is equal to x plus 18 squared. X plus 18 squared.
I thought that we were using
Come on. I'm trying to get through. Anybody have any questions with setting that up? Now, remember, you cannot take the square root through addition. All right, just to show you, again, that's a good question. 3 squared plus 4 squared definitely equals 5 squared. 3 plus 4 does not equal 5. Right, that's the easy way to kind of remember that. If you're unsure, just write up the triple, and you can see you can't just take the square root through addition and subtraction. All right, now let's go ahead and do the math here. X squared plus 900 is equal to x squared plus 36x plus 324. All right, now when you square a binomial, I want everybody to listen up here too, because you got entrance exams possibly coming up soon, and you need to be reviewing all of this math. All right, I don't want anybody to have to start over in Algebra 1. All right, so everybody needs to look at x plus 18. When you square a binomial, there's a quick little pattern I want to show you. All right, the first thing is you square x. That's how you get x squared. You also are going to have to square 18. 18 squared is 324. Now the question is, how do you get the middle term? If you remember, the middle term is just x times 18 times 2. All right, the middle term always occurs twice. Don't be distracted. All right, so that's how I have x squared plus 36x plus 324. Anybody have any questions with that? All right. So now what happens to the x squareds? They cancel out. So 900 minus 324, 576, right, is equal to 36x. And so divide that out, Walker. I think it's 16. Anybody agree with that? Okay, now you just got to go back and make sure that you answer the question. You got to go back and make sure you answer the question. It says find x. So that's all we had to do. All right. Now, again, these two sides here, the 5x minus 8 and the 3x, are both lines that are tangents. All right. So what does it appear to be true? They are equal. And again, it's not really hard to. I mean, it's really simple to prove. If you draw that line right here, draw this down here, draw this right here. All right, you'll see that's a 90-degree angle, 90-degree angle. The radii are equal, right? And the hypotenuse is equal, all right? Which means we're just creating two equal right triangles. That's it. All right, so it's easy to prove that. All right, so for question number 6, anytime you draw a tangent from a point outside the circle, it creates equal tangents. Tell me. But remember, there is something called the hypotenuse leg also. All right, and let me try to explain that. We could just do a squared plus b squared equals c squared, true? If I know two sides of a triangle are congruent of a right, then the third side is automatically congruent. That's one way you could say it. You with me on that? All right. So that's why they named it hypotenuse leg, but it's easy just to understand that particular principle. If two sides of a right triangle are equal, the third side's automatic. All right. So now in this case, we just have 5x minus 8 is equal to 3x. So yes, so x is equal to 4. All right. Now again, let's take a look at the one little word problem here. Let's see what's going on. All right. It says a landscape architect is paving the two walking paths that are tangent. Remember, listen, if it's a distraction, we're not doing it. A landscape architect is paving the two walking paths that are tangent to two approximately circular ponds as shown. The lengths given are in feet. Find the value of x and y. All right, so let's see what's going on here. I don't think that should be too bad, right? We should just simply say what? X plus 250 is equal to 4x minus 500. Anybody have any questions with that? So I end up with x is equal to, I think, 250. Again, making sure you're practicing, like I said. Good job. Mental math. All right, everybody should be able to just say x equals 250. Now that we have x is equal to 250, now you can plug it back in. So this would be 500, and this would be what? 275. And then this would be 500 also, and this would be y. Wow. Yes, that is true. y is equal to 275. All right, nothing difficult. All right, last one for me. It says triangle JKL is circumscribed about circle R. Find X. Okay, so now if I'm looking for X, remember that KN would be how much?
7.
KN would be what? 7. All right, MJ would be how much?
12.
MJ would be 12. And then the only thing left to do is to set 4x minus 9 equal to x plus 3. And of course, we just tell me that x equals what?
4.
X equals 4. All right, I'm not sure what they're asking for here. But first of all, it says find x. So we have that. Then it says find the perimeter. All right. So if x is 4, that means that's 7 and that's 7. All right. Now here, what I like to try to tell kids, instead of doing the perimeter, 12 plus 7 plus 7 is what?
26.
26, right? And then multiply it by 2.
Oh my God.
So the perimeter is equal to 52.
Yes.
All right, the perimeter is equal to 52. No, yeah. Again, these, the same way. The drawings I don't trust necessarily. All right. Okay, so now back to the top here to make sure you're with me. All right, this is the assignment, 1 through 22, 24 through 27, 30, and 35. All right, again, I'm telling you, it's really not that difficult. All right, but I want all the work. I want you to set up the equations. I don't want you to just listen out the answers. I'm not interested in that. All right, there's some equations you need to solve. You got to practice that. What?
From 9 through 12, it asks you to copy down things. Can we just do that on the ability? Do you draw it, or
What do you mean?
should we draw it on the
9 through 12.
No, I mean, you can just draw the shape.
All right.
If you want to do it on the ability, I mean,
Yeah, okay. Do it.
but I mean, that's not that big a deal. All right.
Oh, it's this thing. It just takes up a lot of room. Look at that. I wrote it down. I drew
Two
it.
circles.
Good job.
Look, I drew this.
Yeah, I think you have.
Trees do not need to be saved.